Alrighty, in 9.2 notes, we're talking about solving quadratic equations by factoring. So we are going to go back to using that factoring process that we've used in the last unit. So with this first example, it says, how can you find the solution of the equation x minus 9 and 5x plus 2 equals 0? So this is already factored for us. So our first step, whenever it's already factored, is you are going to take both of your factors and set them equal to 0 separately. So x minus 9 is going to equal 0, and 5x plus 2 is going to equal 0. So you're going to take that and you're going to solve both of these equations separately as well. So you're going to add 9 on both sides, and you're going to find that x equals positive 9. And then on this one, you're going to subtract 2, giving you 5x equals negative 2. And then you're going to divide by 5, which is going to give you x equals negative 2 over 5. So the last step that you can always do is you can check your solution. Now this is important because it might not work when you plug it back in. So on this one, we are going to plug it back into our very original equation, and we're going to plug in both of them. So on the first one, let's plug in 9. So if I plug in 9 minus 9 times a 5 times 9 plus 2 should equal 0. Well, in here, I have 9 minus 9. So that means that 0 times all of this should equal 0. And I know that 0 times anything gives me 0. So 0 times this equals 0. So I know that this was true. All right, let's plug in our negative 2/5. So negative 2/5, minus 9 times a 5 times a negative 2 over 5 plus 2 equals 0. Well, I know over here in this second set of parentheses that a 5 times a negative 2/5 is a negative 2 plus 2, and a negative 2 plus 2 is 0. So that means that 0 times whatever else does equal 0, which means that this is true. Now, you could have taken both of these and plugged them straight into your calculator exactly how they look, and they would also give you 0. All right, so let's practice these two examples on your own. So we are again setting each of our factors equal to 0. So 7x minus 6 needs to equal 0. And 4x plus 7 needs to equal 0. So on my first one, I'm going to add 6, giving me 7x equals positive 6. And then I need to divide by 7, giving me x equals 6 over 7. On my second example, I would subtract 7, giving me 4x equals negative 7. And then I would divide by 4, which gives me an x equals a negative 7 over 4. Neither of these fractions can be simplified, so I'm just going to leave them just like that. Okay, on my next example, it says 10x minus 8 squared equals 0. Now remember, if we have something squared, that means it's times itself. So this would really be a 10x minus 8 times another 10x minus 8. So it's already factored, and we would normally set both of our factors equal to 0. But in this case, they're exactly the same thing. So we really only need to set one of them equal to 0. So let's set that 10x minus 8 equal to 0. So I would add 8 on both sides, giving me 10x equals a positive 8. And then I'm going to divide by 10, giving me x equals an 8 over 10. Now, I can simplify this. So if I type it into my calculator, 8 divided by 10, and I hit math, enter, enter, it would give me x equals 4/5. Okay, let's try another example. So on this one, we have the process of it's not factored yet for us. And the other point that's really important that we talked about in the first unit is that our equation has to equal 0. Now, this one is not equal to 0. So the first step is that we need to write it in standard form. So I'm going to add 20 on both sides so I can get that equal to 0. So that would be x squared plus 9x plus 20 equals 0. So our next step is we're going to take what equals 0 and we are going to factor it. So if you want to make your box, you can. And we want it to become x squared, a positive 20. And we want the diagonals to add to be 9x. Now we know that an x times an x would give us x squared. And if you think about your multiples of 20, we could have 1 times 20, -1 times -20, 2 times 10, or -2 times -10, 4 times 5, or -4 times -5. But if we want to add to be that positive 9x, it looks like 4 and 5 would work. Let's check. 5 times x would give us 5x, plus 4 times x gives us 4x, which adds to be that 9x. So our factors were x plus 4 and x plus 5, and our equation still equals 0. So now that we've factored it, we are going to set both parts equal to 0. So x plus 4 equals 0, and x plus 5 equals 0. So if we subtract 4 on both sides, x would equal -4. And over here, I'm going to subtract 5 on both sides, giving me x equals -5. Now, we can check our solution for this. Anytime, you can always check your solution by plugging it back into the very original function. So if we want to do that, our original function was x squared plus 9x equals -20. So if I take that and I plug it in to my original function, I plug in -4. It would be a -4 squared plus 9 times -4. If I plug that into my calculator, it should equal -20. When I do, it does give me -20, so I know that that solution is correct. I can do the same thing with -5. If I plug in -5 to the original equation, this side of my equation should equal -20, and if you plug that into your calculator exactly how it looks, you get -20 again, which means that both solutions are correct. Alrighty, let's try some of these examples together. The first one is already equal to 0, so I'm going to start off by factoring it. And I need it to be an x squared, a positive 64, and I want my diagonals to add to be 16x. So if you think about your multiples of 64, it could be 1 times 64, -1 times -64, 2 times 32, or -2 times, -32. You could have 4 times 16, or -4 times -16. And you could also have 8 times 8, or -8 times -8. We know that x times x would give us x squared. And it looks like an 8, and an 8 would be 8x plus 8x, giving us 16x. So our factors are an x plus 8 and an x plus 8 equal to 0. So I'm going to set both my factors equal to 0. They're actually exactly the same. So I'm just going to set 1 equal to 0. And I'm going to solve, giving me x equals -8. Now you could check your solution by plugging it back in. And if you did that, you would have a -8 squared plus 16 times -8 plus 64 should equal 0. And if you do it, 0 does equal 0. So you know that your solution is correct. Alrighty, on the next example, we need to factor, but before we do that, it's not equal to 0. So I need to subtract 64 on both sides. So that would give me x squared minus 16x minus 64 equals 0. And now I'm able to factor. So if I go to my box, I want an x squared, I want a -64, and I want my diagonals to be a -16x. So we have the same kinds of factors, but it should be a negative and a positive. Oops. Got to write super small. -2 and +32, 2 and -32, -4 and +16, 4 and -16, or 8 and -8. So if we look at our options, we know that in order to be x squared, it would be x times x. But in order to add to be -16, it doesn't look like any of our options will give us what we need in order to get that -64 and that -16 all together. So that means that this is not factorable. Now, does that mean that this is no solution? No. But we would have to solve using a different method other than factoring. So we've already talked about graphing, and we're going to talk about a bunch of different methods of solving throughout this unit. So keep in mind that all of these different methods are not just for this certain way. They all can be used to solve any of the different problems that we are working with. So we could solve this using the calculator if we wanted to, or we could solve it using a different method that we use throughout this unit. So right now we're going to say this is not factorable, but there is a solution. Use different method of solving.